Alright, so we're going to run through standards 8, 9, and 10, which are all connected to each other, and they all revolve around the mathematics of scatterplots. So scatterplots are for two different quantitative variables where you are assessing the association between the two variables. So for example, the table at the top here, we have an x variable and a y variable. The x variable represents the minutes studying for a test, and the y variable represents your test score. So theoretically, we would expect some sort of a strong association between how long you study and what your score is. So we'll set up an xy plane, and we're going to have to go ahead and label it. So on my x-axis, I need my numbers to go from 20 to 45. I'm just going to start at 0 and choose to count by tens for each of my tick marks, but you can choose to set that up any way that you want. My y-axis has to go up to 90, so I'll just make every tick mark 10, so that way we can go from 0 to 100. Now you don't actually need to start at 0 on either axis, it's up to you, but sometimes it makes it a little bit more visually appealing. So the x-axis is minutes, and the y-axis is the grade. Make sure that you label your axes with both the numbers and the actual units themselves, so the minutes and the grade. Now we're going to go plot each of these points. So the first point is 2075. So I'm going to go over 20 units to the right on my x-axis. So let me maneuver that, get the red pen out here, and then up 75 units for the y-coordinate. We'll do the same thing with 3080, over 30 units to the right, and then up 80 units, and should be a little bit higher than that first point. The next point is 30, 90, so we're going to go 30 units to the right, and then up 90 units. And we can see that that has the same x-coordinate as the previous point. And then we have 45, 85, so over 45 to the right, and up 85. So that just kind of nests in between those two different y values from before. And that is my scatterplot with 4 points. Usually on a quiz or a test, you guys would get a pretty small scatterplot like this with 4, 5, or 6 different points total. And, you know, it's not a lot of data, but it does seem like there's some sort of a positive association. It looks a little bit linear. You could imagine a line of best fit, which we're going to calculate for the next standard. Alright, so now that we have a sense of what our scatterplot looks like, we're going to use the calculator to actually come up with the least squares regression equation, which is also known as the line of best fit. So you're going to hit the Stat button and go to Edit. This is where your lists are. Go ahead and put your X data in L1, and your Y data is going to go in L2. You might want to pause the video and then resume when you're done. Alright, so we're going to hit the Stat button and go over to the right to Calc, and scroll down to the fourth option, linear regression. You could alternatively just hit the number 4. So we're going to live in this number 4. It's going to give us all the information that we need. So what we're going to do is we're going to go ahead and, we're going to come up with our equation for our line. So you can see that it says y equals ax plus b. So the actual proper notation is to put a hat over the y, and that just means that you are predicting the y value based upon the x value. And the calculator should give you the a value and the b value. The a value for our data set is 0.35294-ish. And let's see, the b value is 71.4705, etc., etc. So now we just have to write our equation. You can see that they also give you the r squared value, which we don't really use, and the r value, which we certainly do use, and we will use it in a little bit. So we just have to plug in our a and our b and maybe round them off a little bit to come up with the equation of our line. So y hat equals 0.353, with a little bit of rounding, times x plus 71.471. So that is the equation of our best fit line, and that is standard 9 regression. Now, we might also have a question that asks you to perform some sort of a calculation using your line. So perhaps it says, what if we were to study for 20 minutes? What might you expect for a test score? So we would let x be 20 and plug 20 into that equation. So then we just substitute an x, or 20 for x, and you can use your calculator. And y hat comes out to 78.531. So you might say that, okay, if I study for 20 minutes, I might expect to get a test score of about a 78 or 79. Or you could certainly just use the precise decimal if you want. And that's the entirety of Standard 9, regression. All right, so we already calculated the R value before when we went to stat, calc, and then the linear regression. So the R value for our data set was 0.5636. And the purpose of the R value is it's the correlation, so it tells you how strong of an association you have between your two variables. This is a positive association because the R value is a positive number. So what that means is that generally speaking, as x increases, y should also increase. In other words, the more you study, the higher your test grade. Now, we also want to assess the strength of the association. So the strength is something that you determine on a scale of weak to strong, where a strong association is like something that's close to 0.9, whereas a weak association is something that's close to 0.1, and then everything else in the middle is kind of up to your own interpretation. So I would say that an R value of 0.5636, it's kind of like right in the middle. So I would say that we have a moderately strong association. You could also say it's just moderate. It's really up to you. And it's a positive association because R is positive. So if you had an R value that was like really close to 0.9, you have to say that it's strong. If you have something that's really close to 0.1, you have to say that it's weak. And the same goes for when the R value is negative. So if the R value is negative, your strong values are the ones that are close to -1. And your weak values are still the ones that are close to 0. So ultimately, the scale of weak to strong, -1 is really, really, really strong. -0.8 is still pretty strong. -0.2 is pretty weak. 0 is extremely weak. 0.2 in the positive direction would be weak again. Positive 0.8, very strong. And then 1, extremely strong. And that is standard 10, the correlation coefficient. Again, these three standards are all tied directly together. And if you hit stat calc number 4, linear regression, after you've inputted your data, it basically spits out all of the data that you really need, all of the analysis for all three of these standards. Thank you, guys.